Letter H is Mg2 plus. So we would look on the periodic table. We would find magnesium. There's a couple different ways to do these, and the more you get used to them, the more likely you are to get the correct answer by taking a shortcut. On the exam, though, you want to be sure that you get the right answer, so I would work these through and take your time with them. Ideally, if you write out the electron configuration, then if you have a charge to deal with, you can adjust the electron configuration by taking away electrons if it's a positive charge, or adding more electrons if it's a negative charge. Once you've adjusted the electrons, then you look to see how many of those are valence electrons. So magnesium would normally have 12 electrons to balance out the 12 protons if it were neutral. So we could start there by putting in 12 electrons. But then we know if it has a +2 charge, it's losing 2 of the negative charges that it would normally have to keep the charge balanced. And so we take out the valence electrons first. So that would be the electron configuration for Mg2 plus. So how many valence electrons does it have? 8, right? So it's the entire outermost energy level that's occupied. So you would want to put 8 dots around that. And then usually if there's an overall charge, you would also put it in a bracket and show the overall charge outside the bracket. And the reason for that is because there's another magnesium that also has 8 valence electrons that has a different charge. So we have to distinguish what charge we're talking about. What other charge could we put on magnesium, even though it would be very unstable, to give it 8 valence electrons? -6, right. So if we looked at this electron configuration, which we had a 3s2 initially for the neutral magnesium, and then if we added 6 more, that would also give it 8 valence electrons. So that's 6 more than it would normally have. That would be a magnesium with a 6 minus. So that's going to be really unstable. It's not likely to exist, but you might still be asked to draw a Lewis symbol, a Lewis dot symbol for that element. So that's why it's important that you show the charge, if there is a charge, next to the atom in some way. Yes?
That top one, that's what I thought the answer was. The back of the book has Mg2 plus with 1 dot.
1 dot?
Yeah.
No, that's not right.
Okay. Is A a typo also as bromine? The back of the book has 8 dots. So
It should have 7. Yeah, bromine has 7. If there's no charge, it should have 7. Just to point out also for this magnesium one, kind of a shortcut way to get to this is to look at where it is on the periodic table. Okay, so it's in group 2A, the second column over. So for the group A atoms, the number of valence electrons it would normally have is equal to the number for whatever column it's in. So if it's in 2A, normally a neutral magnesium would have 2 valence electrons. Right, so if we know we want to get to 8, we know we have to add 6 more, which would give it a -6. Or we could take those 2 away. So if it has a +2 and we remove those 2 electrons, you may just see it drawn like that. You may see it drawn without any dots. That implies that whatever that highest energy level was, whatever valence electrons were there, they were all removed. And now whatever the core electrons were underneath are the new valence electrons. And since those were core electrons, sometimes they don't show them. Because, you know, if we had those 2 valence electrons there before, then the 10 core electrons that were inside of that are held pretty tightly and they're relatively stable. So if we remove the outer valence electrons, it's kind of as if it behaves as if it really doesn't have any valence electrons. We know it has 8 if we remove those 2 because that second energy level gives us the 8 underneath. But since those are held pretty tightly, they're not easy to take out, those electrons. And if we were to add more, they would go into the third energy level since the second level is full. So you might see that Mg plus 2 just shown without any dots. But based on the electron configuration, that there are really still 10 electrons present, and 8 of those are valence electrons in the second energy level. Any questions about that? Yeah, so obviously this is the first edition of the textbook, and so it's hard for them to find all the mistakes before they publish it, but we do that job for them, and then we don't tell them about the mistakes so they can still do the work and find them on their own. There is a second edition out that they're going to force us into next fall, so maybe it'll be having less mistakes.